processors,
Okay.
individual processors. So
Here we go.
There will be a delay, a couple of seconds. Here you go. You also need to connect to the Zoom.
Yes. Should be able to start this meeting. Audio, what should I do for the Zoom
You
audio?
can select the.
I guess I probably want the speaker's mic.
Yeah, that would be alright, I guess.
Right, it's the other one.
You don't need to capture the video. You just need it for the slides.
Okay.
Can you also change your name to LTD1414?
LT1414A, yeah. Did I do that in here?
Right click. Yeah, rename.
There we go.
Okay, another capture for the Zoom.
Yeah, maybe you want this up in like the corner and then
Display
application,
capture.
window capture. Zoom workplace, Zoom meeting. I guess it's the yeah. Windows 10. Cool. Okay, how does that look on the?
I think you need to click the fit to the screen because there was a gap on the left side.
It should be. Oh, it's fitting to screen and then it's not getting to see the whole thing. There we go. Hopefully. No, there's still gaps. Weird.
No, there will be some delay. Let's wait a couple more seconds. Yeah, this is fine. Here. Do you know how to mute the notification?
Oh boy, Razer gaming software. I do not.
No. Gear icon settings and in the
Zoom.
is there settings in the Zoom? Yes, here. In meeting basic section. I think it's in general.
Hello. Doing that.
Good. Is it in video or meeting?
Notifications.
Meeting.
experience your talk.
Yeah.
Welcome to Strathclyde.
Thank you. Oh, very much. Oh, very sorry. Yes.
I was wondering whether you would actually make it in the city's
conditions. Well, I'm looking forward to a storm because I think your tower sways a little bit in the wind. Is that right? Well, the tower sways.
I don't know if it's very solid question to start. Most likely what will happen is it will leak. There's some serious leaking that goes on.
Oh no, well that's the same in our department as well, actually. Yes.
Yes, being on the top floor is bad.
Basically, the PhD students get all the lucky rooms, don't they? Well, certainly on the floor. This room here actually isn't that one.
Do you like the others?
I cannot take the voice. It should be good now. I had it muted for a while while we were setting up just to not echo.
Good. Are we showing the right thing on Zoom? This is very clever because on my monitor it's showing the speaker view and on there it's showing the presenter view, even though I told it to share that screen. Wow, amazing, amazing. Good. Good. Hello, Bob. How are you? Nice to see you. Yes, fine, thanks. Yeah. Oh, it's not good, is it? Yeah. Oh, hi. Nice to see you. Good. Oh, hello. Well, thanks very much. Very kind of you. Yes, I know. Very nice surprise. Yeah.
I'll be doing Glasgow on
Oh, are you doing a plug talk?
Yes.
When's that?
22nd.
Oh, I think I might be around then. Yeah, okay. I'll check and see. Is that a Wednesday afternoon? Normally Wednesdays, I think. Okay, good. Right, I'll try and be there. Oh, that's nice. Good. Yeah, okay. Oh, I'm glad we're having lots of crossovers. Yes, that's nice. Yes. Make the most of the subway. Yes, hello. Good.
There's just a book published on Esoteric.
Yeah.
There's a by an actual artist.
I know. Is this one about 44 languages? Yeah, I've had a little look at it. Yeah, I haven't bought it though. I recommended our library to buy it. But it looks quite interesting, doesn't it? Yeah.
I just thought of it.
Yeah, that's right. Yeah. Tempkin. I cite it in my thing here, but I think, he's trying to make money out of it. Good, that's what artists do, I suppose, isn't it? But, yeah, so there we go. Well, yeah, I suppose so. Yeah. I wonder why there's a hello. Oh, is it time to start? Is it? What time do you finish? Yeah, okay, good. That's fine. I need to catch a train to Liverpool from Glasgow Central at 5:30. So I'll try and finish a little bit early and then run away very quickly. I'm sorry, because I know you can't invite me to stay for drinks, but I need to go and see my mummy in Liverpool. So I'll catch a 5:30 train and get there at 10 o'clock. Yeah, sorry about that. Yeah, okay, thanks. That's a proper old Mac with a light up apple, isn't it? That's quality, that is. Yeah, it's very good. How many years old is your MacBook? Could be at least 10 years old, I think. Is that right? Very nice. Oh, hi, Connor. Yeah. Is it running Linux or are you running Mac OS? Oh, good. Yes, it does look nice though. Can you control the backlight with commands on Linux, or is it always just?
Well, I'm sure you can.
Yeah, it's very nice.
But look, I have the gestures working.
Oh, cool! Wow, so the touchpad is all very nice. Yeah, good.
It's not the oldest laptop I use on a daily basis.
Oh, right. Yeah.
But my other laptop, I have one of the 2005 or 2003 versions.
Oh, wow. ThinkPad. Is that an IBM one? Was that Lenovo? Yeah. Proper IBM. Wow. Respect. When did Lenovo take over from IBM on ThinkPad?
I don't know, but it's
couldn't be much after that.
Before that, because it's also before Intel started putting 3.0 firmware on.
Oh, right.
So it's very old.
Good. Right. Yeah.
I can really miss my old.
Should I just start, or does somebody introduce, or how do these things work? Do you know? Do I just start, or?
Yeah.
Oh, really? Okay, I'll sit down and wait for traditional things to happen. Yes, good. Okay.
So I guess the usual thing is to check for if there's any gossip or otherwise marvelous stuff going on before we give the floor to Jeremy. Yes, Brad. Yeah. So that's marvelous. Now I have to find whether there's a button that I have to press, because in this institution, ridiculously, PhD students are not allowed to say, "Fuck you, I'm shipping my thesis" to their supervisor. And that's just wrong.
They can't, but they have to email with
Yes.
Christy David.
Right. I've got no business preventing Malin from submitting her thesis, even though I want. Right. The other thing that's great, just plug, was that tomorrow evening at the Bonus Hippodrome, there is a showing of Battleship Potemkin with live musical accompaniment. And I'm going, so that was Collington. I was wanting to go and want to make it work, so I can have it. That'd be lovely.
What kind of thing?
So the film is at 7:30 in the evening. Doors will open at 6:30 for sociability and beverages. And I was planning on getting a fish supper for children on the amazing chip shop in Bowness. I mean, there are three amazing things in Bowness. There's the National Railway Museum of Scotland, there's the Bowness Hippo Cinema, and there's Corey's. So yeah, I don't know, I haven't encountered these musicians before, so I don't know what they're like. But Battleship Potemkin is always
Other news, Ella's just started.
Yeah.
And we are organising SPS there on the 3rd of December.
Oh, that's good news. We'll pass that on, yeah. 3rd of December. What day of the week is that? Okay, good.
And there'll be an event in this room in the morning at 8.
Oh, excellent.
Details will come out Friday now next week. And one way thing is I applied for I will be the co-chair of Mathematical Structural Functional Program 2026, and we've just applied to block for this, and if it happens, Marie Kirsch will.
right. That'll be the 20th anniversary.
Yes.
So,
I don't know, if we get accepted, it'll be in Lisbon. With MSP and the rest of the Federated Project Conference.
Nice.
So I encourage everyone to submit their mathematical structure programs. You need pay for just program. Short papers and long papers.
Amen.
Long papers are 50 pages. Right, yeah, you could, in theory, just submit.
A literate one.
Well then, without further ado, this is Jeremy Singer with Let's Take Esoteric Programming Languages Seriously. And take it away.
Thank you. I'm madly jealous. You have much more exciting preliminary meeting chat here than we do in Glasgow. That's wonderful. I must take this spirit home with us. Good. So, as you will be aware perhaps, ICFP and OOPSLA are co-located in Singapore, happening in 2 or 3 weeks' time. And I'm going because the satellite event called Onward Essays, which is largely non-technical, but people stand there and read essays to each other about programming. So I've brought my essay with me, but I don't think I will read it to you literally because it's actually got rather soggy on the way over. But I'm going to give you a kind of flavour of what the essay would be. The title is Let's Take Esoteric Programming Languages Seriously. This is joint work between myself and Steve Draper, who I think is on Zoom. Can you spot him there? He may well be. Steve is from the School of Psychology and he's just retired, so I think he's emeritus now. I'm desperately jealous of him as well. This is a program. It is, and of course you know it's a program, you know it's in white space here. I'm just going to show you, it really is here. Look, there are actually some characters there. You see some new lines and spaces. That is a white space program. Here's another program. This program is written in the Piet programming language. They wanted to call it Mondrian, but that was a real programming language. They called it Piet, which is kind of the first name of the same artist. And here's another program. This is written in the Shakespeare programming language, and programs purport to be Shakespearean plays. So here are some actors here, and this is the start of the play. We'll just do a little bit of Shakespeare programming. Live coding is always very exciting, isn't it? So here is a Shakespeare REPL. How exciting! So I've got 2 characters. These 2 characters are effectively variables or really stacks of values. So Romeo is going to say something to Juliet, and he's going to say, "Thou art a red, red rose." Oh dear. Hang on, he's probably going to put a full stop at the end. Good, right. Now, this is what's happened. This is what's happened here. Rose is a kind of positive vibe noun. So that's +1, right? And the 2 prefixed adjectives multiply that by 2. So we've got 4, effectively. Do you get set to 4? I could have said this, I could have been a bit more mathematical and said, thou art the cube of a red, red rose. And guess what? Now Juliet set to 64. How exciting. And now I can say, here we go, I'm going to say, Juliet, thou art the sum of myself. So we're taking the 64 of Juliet and now we need another noun that's in its vocabulary here. Let's try a toad. Is a toad positive? I really want a positive thing actually because I want to make 65 for reasons that you can probably guess. A positive noun that might be in our Shakespearean vocabulary. Help me out, somebody. A star. That's probably there. Thank you. Oh no! Oh, how sad. It doesn't like that. It doesn't like that. Oh, right. Okay, let's try another rose. Ah, good. Right. Okay. Oh, how annoying. Romeo set 65. And now Juliet is going to say to Romeo, speak thy mind. And Romeo should print out character A. How exciting. Good. So we've basically done a lot of literal constant munging and then printed out, well, the single character A. So there we go. We will leave that for now. But you see how these things work. So this is a little whistle-stop tour of 3 slightly different, but actually not very different, esoteric programming languages. Now, why is this interesting? Here is Alan Perlis, who you may have seen wrote a bunch of epigrams on programming. This was published in SIGPlan notices when SIGPlan notices was a thing a long time ago. And the 19th epigram he wrote says this. I really like this. A language that doesn't affect the way you think about programming is not worth knowing. How nice. So I guess the question is, do these esoteric languages affect the way we think about programming? Interesting. Let's take esoteric programming languages seriously. I guess that's Steve and my plea to the community of computer scientists. This essay is available on Archive, and in fact, if you just Google this title, you'll find it. Someone's even written or produced a podcast about this. They say slightly rude things about us, but it's a 2-hour podcast, so definitely not worth listening to. Yes. But I think this is the observation that Steve and I started with. Esoteric programming languages are surprisingly popular. So I gave the kind of V0.1 version of this talk in SPLS in Sterling maybe about 6 months ago, and some of you were there and will remember it. I hope it's moved on a bit since then. But I asked the audience to put their hands up whether anyone had ever written a program, an esoteric program language, and basically almost everybody put their hands up. Should we try the same poll here? Have you written a program in a weird esoteric programming language? Yeah, so that's definitely about half of the audience. Yeah, okay, that's fine. Good, okay. So somehow esoteric languages are quite popular in computer science. And yet at the same time, people somehow have a sense of shame. You know, it's perhaps an embarrassing thing to admit that, yes, I developed an esoteric programming language, or maybe I write programs in my spare time in an esoteric programming language. So we must explore that too. Some definitions. So what does esoteric mean? I consulted the dictionary, and esoteric is, here we go, something to do with an inner circle of initiates, people who are admitted to this kind of esoteric doctrine. So this is really cultic language here. It's something mysterious and kind of secretive that only the kind of inner circle of people know. What's programming language? This is probably my most controversial slide. Throw things at me if you want. So I've said it's a systematized notation for precise expression of intended computational behavior. So we have kind of static stuff up at the top and dynamic stuff down at the bottom, and some idea of no ambiguity. The ACM Encyclopedia says that programming languages are both tools for directing the operation of a computer and tools for organizing and expressing solutions to problems. Maybe that's low level and high level, or maybe imperative and declarative or something, I don't know, but there we go. So, what's an esoteric programming language? And this definition comes from the esolanguage.org website, a programming language designed to experiment with weird ideas, to be hard to program in, or as a joke, rather than for practical use. So practical use, think C, or Haskell, But esoteric languages are slightly more abstruse than that, perhaps. Right, so this is the actual audience poll that Steve encouraged me to conduct today. I'm not really using Mentimeter or anything like that, so this is how we're going to do it, right? 0, you just put your hand up with no fingers. 1, 2, 3, 4, 5, and if you abstain, you don't put your hand up at all. So, do you think ESO-languages are a significant research area that should be investigated? Hands up. Oh, thank you. Oh, wow. This is very, now, I actually need to take an average for Steve here. Oh, this is very difficult, isn't it? So I can see some 5s, some 3s, a 4, a 1. No one's abstaining. Oh, yes, one person's abstaining. Very good. Okay, thank you. That's very, very helpful. Good. Okay. Excellent. Thank you very much. So what I'm going to do now is kind of whiz through the content of this paper. That was all introductory material. And if this is really interesting, then do please have a look at the paper on archive and do send me feedback. Oh, by the way, interrupts are enabled, so feel free to jump in anytime you like. That's absolutely fine with me. Let's start with a language called INTERCAL, which is really the archetypal ESO-lang. It was developed in the early 1970s by a couple of computer science students at Princeton University. And, well, what were the mainstream languages in the day? I suppose Fortran, COBOL, PL1, was PL1 around in 1972? Lisp. Yes, these are kind of the language that people would have used if they were writing in high-level languages at all, of course. And INTERCAL is really a parody of these high-level languages. So instead of go to for the kind of control flow from a location to another location, instead they have the reverse, come from. So when you encounter the label, that's where you jump to the come from place. So it's kind of the reverse control flow edge, effectively. Literal constants, quite like, I suppose, the later Shakespeare language we've seen, are encoded in very weird ways. That's an operator there. And that's, it's not actually children 56, but it's some kind of value. And literal constants are encoded very strangely, and they go onto stacks. And you can't just say do, which is imperative. You must be polite and say please do. And then the compiler accepts your code. But if you say please do all the time, you get a compiler error for being too cringy. So there's a certain ratio of pleases to your do's that you need to put in. And then the end of the program is marked not by returning from main, but instead by saying please, or maybe you're not feeling so polite, just give up. And that's the final statement of the program. So this is INTERCAL. And as I say, it was invented in the 1970s, but you know, a thoroughly respectable, at least for some measure of respectability, hacker, Eric S. Raymond, really likes INTERCAL and rewrote the INTERCAL compiler and runtime in the C programming language. And now you can brew install INTERCAL or apt install INTERCAL, and it just works on your Unix terminal, which is very nice. So that's something interesting, isn't it? Look, kind of serious computer scientists enjoy playing with esoteric languages. Do you know, I remember Guy Steele doing a presentation about 50 languages in 50 minutes, and number 40-something was the Shakespeare language. So he too is interested in these kinds of, you know, rather obscure languages indeed. I want to talk to you about technomasochism, which is a phrase coined by Ratushenko, and really this is the underlying philosophy of INTERCAL. Look at this. Programmers working in INTERCAL and these ESO-langs seem to derive pleasure from painful software development experience. And think about this. This is really the opposite to what, you know, ergonomic programming language design is all about. And yet somehow we enjoy putting ourselves, or perhaps other people who are using our language, through these kinds of experiences. Yes, so I do encourage you to apt install INTERCAL. The compiler is called IC, and I tried to write myself a Fibonacci program. The error messages are even worse than GHCs. So here's the error message here. INTERCAL error 999I. No skeleton in my closet. Woe is me. I think that's a syntax error of some kind. On line 1, in fact, there we go, on the way to 1, correct source and resubmit. That is actually what it says, resubmit. So here we go. Yes, INTERCAL's interesting. But I want to say it's an archetypal esoteric language because I think it's really genre shaping or defining. So there's this notion of absurd syntax, as you see, and also some kind of satirical take on conventional programming languages. You know, these people are laughing about, you know, Fortran programmers and COBOL compilers and so on. Okay, so that's INTERCAL. And now what I'd like to do is to take you through the world of esoteric languages, and I'm going to roughly divide this, I don't think I should call it a paradigm, this family of languages into 3 different categories. These are loose categories, and actually some ESO-langs might fall into more than one category. So the first category I'm going to claim here is pseudo-natural language syntax. So here these are programs in these languages that don't necessarily look like programs, but they're very easy to read. I suppose a bit like our Shakespeare play, you know, it looks like something other than a program, something very human-friendly and readable, which is quite nice. We'll see that these pseudo-natural language programs are actually highly structured. So you can't take any old item from the collected works of Shakespeare and feed it into the Shakespeare interpreter. The second category is languages that have non-textual syntax, and we've seen white space already in that category. Can you call white space non-textual? Well, I suppose so. And then the third category I'm going to talk about is those that have an unconventional computational model. And you can see here why these categories aren't necessarily disjoint, because this is not really talking about the syntax here, but about the way that the computation takes place. I've selected 4 languages in the pseudo-natural language category. We've already looked at Shakespeare, where programs look like scripts from Elizabethan plays. So here, for instance, is how you say x equals 2, where x is the character on stage that you are addressing. There should always be 2 characters on the stage. That's a constraint, because when you say thou art, you need to know who you're talking to, you see. So I think it's a 2-way conversation, a dialogue, in fact. Thou art a red rose. So we know how this works now. That's 1, and that's multiplied by 2, so that's 2. And then to print the numeric value, we just say open thy heart. So that would output 2, whereas if we said speak thy mind, that would output ASCII 2. Oh dear, that's not very printable, is it? But obviously you'd use a larger character for speak thy mind. You can't print F strings, so you actually have to do character I/O 1 by 1, which is very annoying. I don't think any of these ESO-langs have standard libraries either. Rockstar is very similar, only instead of, you know, 1600s kind of Shakespearean language, instead we've got 1980s lyrics. So you say, let your love be 2, and you say, shout your love. That's exactly the same thing, effectively. Chef is really nice. So Chef programs look like recipes. And indeed, there's a sort of dual interpretation going on here. You can interpret your recipe as a chef and cook your cake or whatever, or you can feed it to the Chef programming language interpreter, and here, there we go, 2 grams chocolate pushes 2 onto the chocolate variable stack there, and then serves 1. I don't know why serves 1 is print x. I think that prints 1 value out, perhaps, at the top of the stack. Yes, and there's other languages. Here's lol code. I has an XR2, visible X, and so on. And these are just examples of this sort of genre of pseudo-natural language things. You can read them and they kind of make sense from a human point of view, or you can interpret them with these program language interpreters. Very few of these pseudo-natural language things have compilers. Mostly they're just interpreters, and they run nicely. Non-textual syntax is my second category here of language. White space has just 3 lexemes, space, tab, and new line, and basically you build up these lexemes to make effectively opcodes in some kind of stack-based system, and you interpret those. Break beep has 8 lexemes, and really, this is a Turing machine. You can move left and move right. You can increment and decrement the value in the cell. You can print the value in the cell or input a value from user input to the cell, and these are control flow for jumping if the value in the cell that you're currently pointing at is 0, and that's to return or to go back to the previous enclosing square bracket. So this is really a Turing machine encoded in this very simple way. The person who wrote the first break beep interpreter was actually he wrote a compiler on his Amiga system, and he's trying to compress it into as few bytes as possible. And in much less than a kilobyte, he's got an interpreter here for this very simple language. And Piet, we've already seen that 2D graphical syntax. And in fact, it's not the colours in this 2D graphic that are important. It's what happens is your program counter starts at the top left and proceeds right. And when you cross over a boundary between 2 different colours, then you take the difference between those 2 colours and look up that value in an opcode table, and then use that as your next instruction. So again, there are interpreters for Piet. Unconventional computation. So there's a range of different languages here. Oh, that's a type, that's just a Fractan. Fractan is a language which is purely mathematical. This is from John Conway. You start with an integer value and a set of fractions, a list of fractions, the sequence here, and then you, here we go, repeatedly multiply the starting integer, that's your input, by the earliest fraction in the list, which the answer is integral. When there's no such fi, the game stops. And he's got 2 beautiful programs. Again, I think this is published in SIGPlan Notices a long time ago. One to compute successive digits of pi, and one to compute prime numbers. Very nice indeed. I think, going back to Perlis, this is probably the biggest problem with esoteric languages. Perlis says, beware of the Turing tar pit, in which everything is possible, the language is Turing complete, but nothing of interest is easy. Because you know these very simple syntactic constructs need to be compounded in annoying and verbose ways in order to make interesting things happen. Okay. Programs themselves can be viewed as different things. So a program's a kind of human-made idea that's used to express some kind of tool, perhaps. It's statically a notational artifact, but dynamically it becomes an entity that you can execute. It can be a physical object, especially if you're actually synthesizing this in hardware, or some kind of abstract entity, perhaps represented with a graphical notation. So programs, all of these different things. And I suppose the artifactual, is that a word, nature of these esoteric programs is something very interesting. Bob was reminding me that just in the last month, a book has been published by an artist, Daniel Temkin. The book's called 44 Languages. And effectively, his book is a series of works of art written in 44 esoteric programming languages. And it's, I didn't buy it because it's quite expensive. I recommended Glasgow University Library to purchase a copy, which I should put on next year's programming languages reading list. But there we go. Should we have a quick look for it? Let's just see if we can find it quickly. Amazon, oh dear, other bookshops available. 44 Languages, Temkin. Let's see if it's there. Oh yes, there we go. Look, The Art of Esoteric Code. Let's see how much it costs. Oh, there we go. Paperback's only $26.68. How exciting. Conventional Thinking of Languages. Write code in the form of prayer to the Greek gods, or as a pattern of empty folders. Type code in tandem with another programmer, each with one hand on the keyboard, rhythm and synchrony signifying computer action. So you can see how these things are slightly far-fetched programming language designs, but it's interesting. Good. Okay, why are we attracted to esoteric programming languages? And this is the stage when in Singapore, in the actual conference, I really am intending to read from my script. I won't do that here for the sake of time, but I think I might just refer to it so that we can kind of grasp the general drift of the argument. So esoteric languages seem to have this enduring sense of appeal from, you know, the 1970s to today to lots of computer scientists, and particularly, I think, to people who are interested in programming language research, like Guy Steele. So why are programming languages popular? What's their attractiveness to us? And I've got 5 reasons here, which I'll go through quickly. So the first one is the idea of fun or playfulness. And I'm going to suggest that a stereotypical hacker has this kind of sense of playfulness. That's what Eric Raymond says. Look, hackers are a playful bunch. We'll hack anything if it looks like fun. There's a bit of the mad scientist in all hackers ready to discombobulate the world and flip authority the finger, especially if we can do it with snazzy special effects, like the kind of weird syntax about esoteric languages. So I'm going to claim this is somehow an anti-authoritarian attitude. We program, but in a way that's perhaps a little bit discourteous to people who are trying to read our programs, or at least understand them. Play is somehow more about the process than the outcome. And I think that's true for esoteric languages. You know, you're not going to write your program in an esoteric programming language because you think the output is interesting. It's more like the process is good fun, perhaps. For instance, does anybody here do the advent of code? There are 24 problems. I normally stop after about problem 6, but never mind. 24 problems that come out, you know, the first 24 days of December, and you should solve these in the language of your choice. Lots of people solve these advent of code problems in esoteric languages. And for instance, if you did a Google search for advent of code in BF, there are lots of attempts. So there is some kind of non-trivial intersection between people who like esoteric languages and people who enter coding competitions, which is interesting. Here's Perlis again. Listen to this. Esoteric languages preserve a sense of fun in programming, and Perlis says, I think it's extraordinarily important that we in computing science keep fun in computing. When it started out, it was an awful lot of fun. I hope the field of computer science never loses its sense of fun. Isn't that a nice quote? And I think maybe that's something that esoteric languages capture in spirit. So a sense of fun and playfulness. Here's the second thing. This is a sense of nostalgia. That's the first computer installed in a Scottish university, installed just up the road in Hillhead back in 1957. But, you know, I think all of us somehow hanker back to a golden age of coding. In our own personal experiences, do you remember your first computer? I do. It was an Amstrad CPC with a Z80 CPU, and maybe you remember something a bit more recent or perhaps a bit older. But, you know, we hanker back. But that's not just true of us as individuals, that nostalgic sense of my first machine and my first programming language. I think even my first editor, yes. But I think even as a community, we kind of hark back to, you know, the golden age, well, really the sepia or grey age when computers were big and, you know, programmers were real programmers. So here we go. It's often the case that experienced developers enjoy wearing the hair shirt. Simon Peyton-Jones talks about hair shirt very often, doesn't he, when he talks about Haskell. This involves putting ourselves through difficult experiences while developing supposedly more elegant code. Turing had this idea of complexity being deferred to the programmer rather than the machine. So Maurice Wilkes has this amazing quote about Turing, where Turing didn't want to use hardware interlocks, which most of the computers in the 1940s, 1950s, the early computers did use, right? He wanted instead optimal coding. So I suppose a bit like pipeline bubbles in MIPS and things like that these days, you know, you have to code around the machine's kind of timing constraints and things like that, rather than letting the machine kind of, you know, wait for your next instruction. So he talks about this extra hardware to make programming easier as being, I wish I could do a Turing accent, much more in the American tradition of solving one's problems by means of equipment rather than by thought. I wonder if I should say that in the conference where there'll be lots of Americans, but never mind. And there's a wonderful, look at after, there's a wonderful anecdote about Mel the hacker from Royal McBee. who works on a rotating memory machine and uses this wonderful, you're familiar with it, good,
Yes.
look up afterwards, it's very nice. But the idea is you should program in a really optimal way so that your code does exactly the right thing in the smallest amount of instructions. So there's this nostalgic attitude. Programming should be challenging. My colleague Steve expressed this as the, have I got this here, the kind of thought to compilation ratio in terms of time. The proportion of time spent thinking should be higher relative to the proportion of time spent compiling or executing code. And that's not true for the average first-year programmer these days, is it? There we go. A sense of belonging, or as I put here, a sense of cultic initiation. So here's the Pythagoreans worshipping the rising sun. All these images are Creative Commons or public domain. Yes, so how's this? Language often serves as a powerful marker of community or group identity. And fluency in a language indicates you belong to that community of discourse. So that's true for natural languages. How many people here speak Klingon, for instance? No? Oh, well. But yes, the point is, you know, if you speak a language, then you somehow belong to that community. And that's true for programming languages as well, isn't it? And I think esoteric languages engage with this notion of cultural identity. So esoteric languages foster a sense of community where an inner circle of people engage in programming in a particular language. So programming now is not just in terms of practical tool making and usage, but a source of aesthetic pleasure and belonging to a group of the initiates. Transmission is very important in this notion of cultic initiation. Transmission involves spreading the joy, kind of initiating new people into the community, sharing the message, the evangel, if you like, here. And unlike mainstream languages, which are generally communicated via textbooks or formal instruction or MOOCs or asking an LLM what to do next. Instead, esoteric languages are learned through more elusive means, scattered resources across the interweb, word-of-mouth exchanges, personal, here, would you like this tarball kind of thing. And, you know, that's quite a different way of transmission, isn't it? And this difficulty in accessing the esoteric language knowledge perhaps shapes the learning process and contributes to a sense of mystique. Right, so there's cultic initiation. Artistic value. I love Fred Brooks's quote of the sheer joy of making things as being the primary motivation for the creative act of programming. And I think even, you know, great computer scientists like Knuth recognize that code has an aesthetic value. They talk about the art of computer programming. So the program itself is somehow an artistic object, and I think that's something that's emphasized in these esoteric languages, whether it's something you view or something you sing or something you read. It's something beautiful in a certain sense. The Programming Language History Museum in America does have a software art exhibition. There are punch cards on, has anybody been there? I haven't actually really seen photographs. Yes, there are punch cards on the wall and kind of decks of code and things like that. Live coding is another artistic form of expression, isn't it? And sometimes you generate music, sometimes you're just kind of coding for the sake of it, but fluid kind of editing of code in real time is I suppose, a performance in that sense, whether it's to your undergraduates or to, you know, a concert hall, whatever it might be. So programming as art. I think another thing that esoteric programming languages teach us is that there's pedagogic value in them. Learning a new language is always important, and it's well known in the computer science education community that early exposure to multiple languages is widely considered beneficial for novice programmers. Conceptual transfer from one language to another. For instance, in Glasgow, we start them off with Python, and then move them on to Java, and then C, and then Haskell. And that's the kind of flow. You're probably much more civilized here and start with Haskell. Do you? No? Oh, sorry. What do you start with?
Well, the people who think they're teaching programming start with Java.
Really? That's interesting. Okay.
Meanwhile,
Yeah.
in modules that are allegedly nothing to do with programming.
Oh, is this your hardware, your electronics?
So
Yes.
the hardware module
Yes.
features a domain-specific hardware language called Syrup. And since I took over our machines, languages, and computation module, we use another esoteric language called Ask, which is the fragment of Haskell.
That isn't hell. Yes, I remember you telling me about that. Very nice. Very nice. Yes. Good. Okay.
And I was going to say, you know, the principal advantage of using esoteric languages in educational context is that ChatGPT has not been trained.
Yes. The corpus is so small and so scattered that LLM code synthesis doesn't really work. That's true. Thanks, Connor.
In particular, we found that LLMs think Syrup is probably Python.
Right. Okay.
And my engineer asked very carefully so that the questions look like Haskell, but the answers don't.
Okay. Very interesting. Yes. I think there's a lot we could borrow from your strategy there, perhaps. Yeah, thank you. There are concrete instances of esoteric languages being used in university courses. In Georgia Tech, course 2700, Introduction to Computational Media, uses the Chef programming language. That's one with recipes and so on. Yes, so I think esoteric languages might be used to show you that syntax is perhaps very surface and you know, the form of the program is only expressed with that and not the actual meaning. You might recognize that high-level concepts are built on top of these low-level concepts and operations. An esoteric language interpreter itself is probably the right size and scale for a student project or a piece of coursework. So I think there are lots of different ways in which you might use ESO-langs to help people learn programming and programming languages. How's this? For programming educators, like ourselves, I suppose, esoteric languages offer the opportunity to experience similar levels of frustration as the average novice programmer does with a mainstream language. You might be adept at expressing quicksort in a handful of Pascal lines, but what happens when you try to write a sorting algorithm in Shakespeare? So you see, that sense of helplessness that we've forgotten about, perhaps, comes back when you're in this very weird and, you know, unusual programming domain. So I'm saying that ESOLang could be an empathy enhancement tool for programming language educators.
Do you at some point stop thinking in Shakespeare?
I haven't got there yet, but I suppose it's possible. Yes, good. Right, very quickly, because time's running on with us. Why do people develop esoteric languages? Interesting, it's mostly students and it's mostly males. I talk about it more in the essay, that's interesting. But why do people develop esoteric languages? I've got three reasons here. The first one is comedy, and that's the most generally asserted reason for developing an esoteric language. You know, humour. INTERCAL is definitely humorous. The language manual says, any resemblance of the programming language portrayed here to other programming languages, living or dead, is purely coincidental. And it's kind of very, you know, tongue-in-cheek right the way through the manual. White space was publicly announced as an April Fool's joke in 2003 on the /dot site. And Edwin Brady and, oh dear, Chris Morris, was it? Whoever else invented white space, were actually implementing an idea that Bjarne Strustrup had suggested a few years earlier as an April Fool's joke. So ESO-langs are comedic in value. But there's so many of them that I don't think everybody's kind of pulling our leg with esoteric language. I think there are other reasons for them as well. And one is challenge, the idea of working within very tightly self-imposed constraints. unorthodox syntax and structure. Constraints are ever present in an esoteric language. Let me just see what this reference is here. I think it might be the /developer survey, my reference here. Let me see. Oh no, IEEE software. What do we know about developer motivation? Apparently, many developers report challenging problems are a key intrinsic motivation for their productivity. They only work hard if something appears to be difficult. That's interesting, isn't it? So, esoteric languages improve that, perhaps. And creativity. I think there is such an attraction, isn't it, creating a language of one's own. Well, you know that, Connor, but I think it's so nice, isn't it, say, and this is my language. Yes, so I think esoteric languages are perhaps easier to create than mainstream, widely used languages, certainly more interesting, perhaps, and they're vehicles for creative exploration and experimentation, and maybe that's the main reason why people develop these esoteric languages. So let me conclude. I'm going to say esoteric languages challenge conventional thinking in terms of both programming language design, what should a programming language look like, and the nature of programming itself, why and how do we program. And I'm going to finish with Perlis here. A language that doesn't affect the way you think about programming is not worth knowing. So I hope esoteric languages, and maybe this brain-tickling talk today, affects the way we think about programming. Thank you. And I'm desperate to get questions off you, right, because there'll be lots of people in the audience when I do my real essay, and they're all going to ask probably exactly the same question as you. So this is my dress rehearsal. Please, Bob, yes. Oh, yeah, the kind of categorization of esoteric language. Yeah. It's here somewhere. Yeah, okay.
My perception is the third one somehow should be most interesting.
Yes, okay. So the only languages I had in the unconventional computational model were Malboj and Fractan. Yes. Hello.
Shouldn't brain count as...
Well, so I don't think so, because if it's just a Turing machine, is that an unconventional computational model? Is it? Oh.
I mean, probably yes.
Oh, okay.
But it's not conventional programming, or it's not an unconventional computational model, it is an unconventional programming model.
Ah, thank you. That's a good distinction. Thank you. That's very nice. Okay. So in my essay, I think, unconventional computational model, right. I do mention BF in the unconventional section, but I say, what do I say? Yes, it's a minimalist language with a small set of operations closely resembling Turing's model of computation. Yeah. Hello. Yeah, sorry.
How do you feel golden languages?
Oh, that's nice. Yes.
Kind of
So tell us about golfing. Yes, this is the idea of expressing computation in a smaller set of...
so trying to write programs that are program as
smaller sequence of characters as possible.
And these often have they use every single possible character. They have a bunch of basic operations. Just all a single character. And you get these nonsense strings of 7 characters that reverse list and then do some weird things.
I know, that's very nice. Yes.
But they are they also have these weird syntaxes, but they are different in the sense that they are made with a very particular purpose.
Yes. So do you have kind of super operators in Golf languages that do kind of very specific things just to solve this particular problem, or?
Sometimes.
Or not?
Yeah.
Oh, right, okay. I need to write this down. Hang on, I need to get a pen.
Well,
good. Yes.
I know some of these languages do a funny thing where they make the empty program be a specific program in order to maybe the empty program is hello world, and then you can say, oh, I got hello world in 0 places.
Very good.
I do think there are functions like capitalization, that are commonly.
I see. Yes.
Commonly
The string processing and so on. Yeah.
Various string processing problems that are proposed.
Right. Okay. Okay, that's very interesting. Thank you. I haven't mentioned those at all, but that's very interesting. Yeah, thanks.
So, question from online.
Oh,
what
thank
do you
you.
think about languages like APL that are real serious languages, but have
Yes.
almost attained ESO-lang status today?
Yes, yes, that's very interesting. So I would count APL as an obscure language rather than esoteric language. And I think there is an active community of professional APL developers. People do use it for real problems, and you can actually buy APL SDKs and things like that. Yeah. How do you distinguish between an esoteric language and an obscure language? That's interesting. Ooh. Oh, hello. I suppose so. It wasn't always, but it could be now. Yeah. Oh, very much so. Yes, yes, yes. I think so.
I am curious, just because I actually haven't heard of it. Is the Conway language is it Turing?
I don't know.
It includes interesting machine, but yes.
Yes,
I mean, you're always working with a number, and if you do it to prize, you have a decomposition that gives you a series of registers. That's how the dividing and multiplying by fractions works.
Wikipedia says it's Turing complete.
The comment about COBOL is well made, hence the joke which I shall not tell. You can reconstruct from the punchline.
Oh God.
Which is Mr. Johnson, welcome to the year 9999. We have reanimated you because we gather you have COBOL experience.
Very good, very good. Yeah, thank you. Oh, hello.
Yeah, I have another question. This kind of gets at maybe the fuzzy line between models of computation and
Right.
programming languages. How do we feel about all these kind of silly ways in which people have proven certain things are Turing complete? I've seen demonstrations that like Excel is Turing complete. Is Excel Turing programming?
That's very interesting. Yeah. And I think Minecraft as well. For instance, you can think about Minecraft. Yeah. Okay.
PowerPoint.
Oh yes, PowerPoint too. Yes, I've forgotten that. Yes.
So can it be an esoteric language if it wasn't constructed
intended
to
to
be?
be?
Yeah, exactly. Is that one of the prerequisites?
That's very interesting.
Well, you can have a degree of,
accidental programming languages. Yes. Okay. Thanks. That's very nice. Yeah.
And of course, the same behavior which prompts the creation of entire esoteric programming languages can also provoke esoteric behavior in the programming languages.
Oh, you're thinking about the international obfuscated C competition and things like that, perhaps?
Not just that, but even just the kinds of fun you can have.
Okay.
E.g., with like making type classes.
Oh, right. Okay. Yes, I suppose back in the day this was like templates stuff in C++ as well. Yeah. Okay.
There's a series library in Haskell called control new type, which contains a function called a third-order function called ala, which I wrote. So you say things like traverse à la const, which is bulma.
That's nice.
Various other things like that.
So would that be an esoteric DSL?
Yeah.
Okay.
Basically pushing the actual program into the type.
Oh.
There was a project a few years ago by Tom Seppen who did machine learning with only linear functions. Because of course, linear functions still have floating point. It's like imprecisions, which you can cram open and make very non-linear functions out of linear functions.
Wow.
Hello.
Yeah, no, I was just thinking of maybe another way in which theoretical things, which we don't think of as esoteric programming, in a certain way are a very formative experience for me when I was initially a high school student. I was interested in programming. I wanted to be interested in video games, and I went off that path
is I went to this MIT Splash thing that was done with my school or whatever.
Yeah.
And I went to this one talk where what they did was they had they introduced the untyped Monday calculus, and they built a Turing machine on a whiteboard, you know, using church encodings and all that horrible stuff.
Yeah.
And I feel like in spirit, it's very similar to esoteric programming language.
I would say it's the Turing target for sure.
Yeah, no, it's the appeal of, you know, it's the pleasure and the pain, right?
Yes.
And I found that very pleasurable. That kind of, I looked for more fixes, or, you know, C++ template meta was another. I found a lot of pleasure in these kind of painful things. Now, both C++ template meta programming and lambda calculus are hugely useful tools, but using them to write normal programs is a painful thing.
Agreed.
Is verging on an esoteric programming.
Yeah. Thanks. That's very interesting.
Jeremy, while you've been wafting your paper around, you keep giving us glimpses of what looks like an XKCD.
Oh yes, there is an XKCD comic about esoteric languages. So I see if I can find it very quickly. It's quite funny actually. Wow, Simon, you've got sharp eyes. Here we go. Let me make it bigger. I've developed a new programming language. Didn't a judge order you to stop doing that? Higher courts without ruling our back, suckers. I promise it's good this time, just normal code, good clean syntax, nothing weird, okay. So the only variable name is x. To refer to different variables, you have to write x in different fonts. Yeah, so. Very nice.
It kind of reminds me of that. Do you remember this website where you can enter your phone number, except it's all of the least ergonomic ways to enter a phone number?
Yes.
Yes. There's like a challenge for like making a UI. It's like ordering dates by alphabetically.
Yeah.
Good. It's 5 o'clock. We need to stop. Thank you so much for all your input. I really appreciate it. And thank you. You don't normally have talks like this, and you don't normally have talks on Friday, so I really appreciate the latitude you've given me. Thank you, everybody.
So you asked us whether research in Asian languages was worth it, but
Oh, yes.
what did you envision? Developing more languages?
Yeah, so I think Steve is interested in the psychology of programming language design, whereas I'm more interested in the pragmatics, I suppose. But yes. Watch this space. Thank you. Yes. Good. Should I?